Okay, now let's do a problem. Okay, now can I expect you guys to do this on your own? No, and I agree with you, because this is something I really have to explain. Okay, so let's read the question. Who's reading the question?
How to set up an equation for force on a mass attached to a string revolving in a circle. What does it depend on? Ignore drag forces.
So now let's talk about it. It's asking us to do what? There's a mass attached to a string and it's moving in a circle. So there is a mass attached to a string moving in a circle. Does anyone remember what we call that force? There we go. It's called a centripetal force. Why do we call it centripetal force? Because it's, yes, it's because it's center seeking. It wants to go towards the center. What do you think it depends on? Okay, don't say anything. I'm just going to give you some hints. What happens if I make this mass bigger? What happens if I make this string smaller? And that circle goes like this. What happens if I speed it up? What happens if I change gravity? All of these things can be possible, right? But what does this actually depend on? It depends on mass. What else does it depend on? Does it depend on radius? Yes, Amanda? The tension of the string, okay. What else does it depend on? Oh, the radius. What else? Does it depend on its speed? True. Can we just call it velocity? Who said that? Sorry. Oh, yeah. So let's just say it's just velocity. I'm just going to call it velocity. I'm going to call this mt radius r, but in dimensional analysis, this becomes L, and velocity v becomes L and t minus 1. What's wrong with this picture? Can t be in dimensional analysis? Tension. Can tension be in dimensional analysis? Why not? It's not one of those three things. So we automatically know that I agree with you. Tension should play a role, but not in dimensional analysis. Okay, so I'm just going to say that one goes away. We're left with these three. Now let's see how they are related. So I have, pick a color, guys.
Purple.
Purple. Sorry, I heard purple first, so I'm just going to go with that. So when you do dimensional analysis, you have to go, force is proportional to mass. It is proportional to radius. Oh, actually, no, not radius. It's proportional to the length of the string, right? And it is proportional to velocity. So now I'm going to write these. So now let's convert this. So force on this side, anyone want to tell me what it was from just a minute ago when I told you? ML t to the negative 2 proportional to M alpha L beta, and velocity is V gamma. Why do I write alpha beta gamma? Because I do not know how these are related. So now I'm going to rewrite this because velocity cannot be part of it. It has to be in M, L, or T, correct? Okay, so that means it has to be M alpha, L beta, velocity was L gamma, and T minus gamma. You see how that happened? bubble heads. Make sure we understand this because it's kind of important. And then I can rewrite this as M alpha L beta plus gamma and T minus gamma. Make sure we understand that. Are we good?
What's velocity doing at the top there?
What's velocity doing where? So right now, all I was doing was copying this over to this one. And then we started doing dimensional analysis. Then it has to be reduced down to its core, right? So now this side is M L T minus 2 proportional to this. Okay? Yes.
Are there supposed to be 2's on the far side?
2's on what side?
On the far right, on all the T, the V, the T, and the last T. Are those 2's or are those?
Wait, what?
He was wondering if there was, if T was to the -2.
Oh, no. Okay, so you guys want to change? You want me to change gamma?
No, it's fine.
We can call them ABCs.
What are they for? Is it just to distinguish them from?
So we're looking. So remember the question?
Yeah. Okay.
We are trying to figure out how they are related. Okay, so give me a second and it'll make sense.
With the alpha beta gamma?
Yeah.
Okay.
So unfortunately, I ran out of space. So I'm just going to keep going this way. So now here's a trick. Compare coefficients of M on both sides. What's the coefficient here of M? What's it on this side? You can call them ABCs if you want. If my alpha, beta, gammas are confusing. No? Okay. What about L? What's the coefficient on this side?
1.
And what's it on that side? There we go. What about T? Equals? Good. So the coefficient of alpha is 1. Coefficient of gamma is 2. Coefficient of beta, so plug all of these in this equation. What do you get? FC equals M, alpha is 1, L is -1, yeah, -1, and V is, which means it is mv squared over r. Is that the formula for centripetal acceleration? This is how you develop formulas.